Alright, so I want to thank Voxel for supplying the filament for this project video. This is their Ice Clear, and I'm reprinting my 4-sphere rotor, and it's coming out great. So these guys are great. They're supplying the filament for this video. $16 a roll. If you get 3, it's free shipping. So check out the link in the description. Voxel PLA, the most reliable filament on earth. Well, here it is, all done. And you know, clear PLA is really hard to print sometimes, but this stuff came out great. This is called Ice Clear from Voxel. So once again, thank you, Voxel, for supplying the filament for this build. The most reliable filament on earth. All right, so according to a lot of comments that I've gotten and testing, these wings that I have on this rotor here don't really speed it up. In fact, I think it might have even hindered it. So this basic design, which I printed from that ice filament, is probably better. What I'm going to do is take the magnets out of here and put them in here. But what I need is a flat piece of steel, and I have it coming in because for the life of me I don't have one here anywhere. I'm going to put it on, and the flat piece of steel is for changing magnets out, especially when they're this close and they're all N52s. The steel sits like this and the magnets will stay put. That's why I normally do it on my bandsaw table. Big cast iron table really helps. And this guy here, which printed out unbelievably beautiful, is for another rotor with probably the most dangerous magnets I've ever purchased. So stay tuned for that. But first, we're going to do this guy. All right, so this is what I was talking about before, having a metal plate. This is not the one that I bought. The one that I bought is still on its way over, but I found this really thin, it's like it's about 16 gauge sheet, but it still works really good. And what that means is when I take this apart, the magnets won't fly and hit each other because they're being pulled down to the bottom. It would be better if it was thicker, if it was a thicker gauge, and I think I have a 1/4 inch coming, but this works really good. These are N52s. All the magnets I get now are N52s, and I'm going to transfer them into this new housing that I just printed out. Yeah, the Ice, I think it's called Ice Clear. But yeah, that's pretty tight there. So I'm going to take this apart, get these guys in there, and then we'll set up the this stand here at the maglev. I don't know if you guys can see that there. Let me hold it down. That's a maglev right there because that's 2 opposing magnets right there, and the weight of the rotor puts it right about there. Anyway, stay tuned. Damn, I got to tell you, it was even hard with this like this. So I've got lines on here, so north, south, and these are a press fit in here. So once they're in there, they're okay. But just getting them out of this guy here, I mean, thank God for this, otherwise it would never happen. And I had to use this magnet that from a rotor that broke. I had to use this to actually get them out of this. I had to, what a pain in the ass. That's what you get when you deal with N52. So now I'm going to screw it together and get it all set up. I've got these little recesses in here, which should screw it no problem. I think these are stainless steel. Yeah, that'll work. I don't want to tighten it down too much. I want to do the rest by hand. stupid song stuck in my head. Raindrops keep falling on my head. All right. I think that's it. This one can probably go down a little bit more. Now I just got to transfer the bearings from these guy here. Put it in here. You guys don't need me to see me to do that. So yeah, a plate like this is essential for doing work like this with a lot of magnets. And I have a lot of magnets, man. I can't even tell you how many I have. But I've pinched myself too many times to not take precautions. And a plate like this really helps because it keeps everything stationary. You know, I can put that there or whatever. Yeah, it just keeps everything stationary. So let me get these guys tightened down a little bit more. Really nice. And it stays put. All right, stay tuned. All right, so I got it in there. Working great. What I have to do though is I have to figure out something else better than this because these things come out all the time. My last one didn't do that. I had different setups. And I know it's just a matter of me sitting down and thinking it through, but yeah, it's in there. It's working really nice. I'm going to put this guy back on top. Hold on, I'll show you this guy. This guy's going to go back on top here, but I need to first put a collet, or a, what do we call these things? I think these are called collets. There we go. Looking cool. Looking very cool. All right, now I got to figure out what circuit I want to use, if I want to do a dual or if I want to do a single and have one of these ends going out to the bridge rectifier, fire up a bunch of lights, see how much power I can get out of this guy. When I press, oh man, I ruined the print a little bit. Got all kinds of, see, the bad thing about these clear prints is that they get charred up really easy. I mean, it's still really nice. Printed out beautifully, nice and accurate. I have to change, though, the size that I do. The openings for the bearings. I make it I make it 1/10 of a millimeter too small. And that generally works, especially with prints like this that I got from PCB Way. But when I'm printing off of the bamboo, I think it's a little bit too accurate or something. And sometimes it works really good, sometimes it doesn't. I don't really know. Let me get this thing wired up. I don't know if I'm going to do it that way. If I'm going to do it this way, probably do it this way. Yeah. Stay tuned. All right, so I've got it hooked up. This is my big sky coil that has a pickup side and a run side. The pickup side goes to the bridge rectifier over here, and then goes to these 3 lights, and it works really good. That's a great bridge rectifier. It's got a big beefy rectifier on there, a nice big capacitor. But let me get this guy pumped up here. Yeah, sometimes with these you got to get them going in order for it to really pick up. I don't know what that's all about. But these are spinning on 1, 2, 3, 4 different bearings. So I can hold the shaft and it still spins, but it also spins the shaft. You can see this guy spinning on there. I can hold it and stop it. So it's starting to really speed up, and you can see over here it's lighting the 3 lights. Those are each 12-volt lights. They're AC/DC lights. I think I ruined one of the bearings when I was pressing them in there. I think I cocked it, because even though it does work fine when I hold this, that's how it. Yeah, I think because I can feel it when I hold it like that. I can feel it. Yeah, if I hold it like that, I can feel it kind of grinding. Not grinding, but. And this guy's just up there for a little balance. I could put a couple of coils up here, and see what I can get out of that. But I just wanted to print it out on this new filament that I got from Voxel. And I like it. I like the filament. It prints out really nice. I should take a reading on what's actually coming out of the, oops, put this back down here like this. Take a reading what's coming out of it. Coming out of the bridge rectifier. No, that was the wrong one, duh. So the plus is right here. We gotta turn it up. Too much voltage. 25 volts coming out of there. Normally I get a lot more, but because of the lights. Yeah, 25 volts. Alright. That is very cool, man. Let me come back over here and move this puppy. I should probably get some of my old batteries out and start charging some of those guys up using this system. But anyway, I wanted to just see how that guy flowed with the new filament. It came out really nice. Again, I can stop this. Yeah, so it's really got a lot of flow because I'm using all 4 bearings. One down there, 2 in the rotor itself, and then 1 up top. But I got to figure out a better way to support these bearings. It's a pain in the ass. Yeah, I definitely ruined the bearing there. Getting a lot of nice output. And this old plate worked out pretty good too. I don't have it securely hooked to this thing. I just have tape. I just have it taped down, 2-sided tape. What I need to do though is glue it down. But I'm not going to spend too much time on it because, like I said, I've got the other one coming in. Pretty cool, huh? All right, guys. Thanks for watching.